63, letter A. You have zinc and hydrochloric acid reacting to form zinc ion and hydrogen gas. Look at the oxidation numbers first. Zinc is by itself, +1, -1, +2, and 0. Look to see what has changed. Zinc goes from a 0 to a +2, so it's gone up 2, it's been oxidized. And here hydrogen goes from a +1 to a 0. It's gone down 1 and it's been reduced. We want to separate out the half reactions. So I typically draw in kind of a dividing line to separate them out. So this is the oxidation half reaction. And this is the reduction half reaction. Okay, so the substance that's been oxidized is zinc being converted to zinc ion. Alright, it's already balanced for atoms. We now need to balance for charges. We can skip all of the steps up to step 4. So oxidation means the loss of electrons, and here we actually need to show the loss of electrons. It's a +2. We need to have 2 electrons to make this neutral on this side to balance with a neutral zinc atom on this side. Alright, so we're done with that side. The reduction half reaction involves hydrochloric acid, and it's being converted to H2. Alright, so we'll balance for atoms here. We have 2 hydrogens here and then 1 here, so put a 2 out in front. Now we have 2 chlorine atoms, and there's no chlorine here. This is a strange example. There's not a lot like this. Just take my advice here that you just need to add chloride ion. The reason that this is okay is because chloride ion is a spectator ion, and that's how I know that I can add it. I'll try to stay away from examples like this since they're a little unusual. In order to balance this, we'll have to add a 2 out in front. Now here, we have hydrogens balanced, chlorides balanced. We now need to balance charges. It's -2 on this side, and we want it to be -2 on this side as well, so we'll add 2 electrons. Remember that reduction has to do with a gain of electrons, and oxidation has to do with a loss of electrons. So we can see that we've lost electrons. They're on the right-hand side. Here we have gain electrons. They're on the left-hand side. What we want to do now is add these 2 reactions together. So zinc and zinc ion and 2 electrons. And here we have 2 electrons, 2 hydrochloric acids, a hydrogen molecule, and 2 chlorides. So if we were to add these up, this is step 5 up here, add the reactions together, we would have, or we would want to see if it simplifies first. So everything on the left compared to everything on the right. Notice that the electrons appear both places. That's intentional. 2 electrons gained, 2 electrons lost. Those cancel out. So now we'll rewrite what we have left over. We have zinc and hydrochloric acid yields zinc ion, hydrogen, and the 2 chloride ions that we ended up adding to make the reaction balance would be present in this solution anyway because they're spectator ions. This is number 63B. It's a redox reaction in solution, acidic solution specifically. And we have iodide ion, hypochlorite ion, gives us I3 and chloride. Alright, so here we want to see what the oxidation number changes are. This is -1, -2, so this has to be +1. This is -1. Now I skipped over this one because it's a little different than the rest. Here we have 3 iodine atoms that are bonded together, and they have an overall -1 charge. So you can have something called a non-integer oxidation number. You can think of it this way. When we're doing these oxidation numbers, we treat all of the atoms the same, but it doesn't necessarily mean that every single iodine atom here has the same oxidation state. So in this case, it doesn't work to give it a 1 or a 2 or a 3, whether it's negative or positive. We can't have 3 atoms giving us a -1 charge. But if each of them contribute 1/3, and they're each negative, 1/3 times 3 does give us a -1. Don't worry about it. Just figure out what it would have to be. It doesn't make it any more difficult other than just figuring out what the fraction is. But after you figured it out, we're good to go. From here, we would want to see what has been oxidized and what has been reduced. So in this case, iodine goes from a -1 to -1/3. So it's actually increasing its oxidation number, so it's being oxidized. And let's see, chlorine goes from a +1 to a -1, so it's going down 2 and it's being reduced. So we want to separate out the half reactions. Oxidation and reduction. And here it would be iodide ion being converted to this ion, and the reduction reaction is hypochlorite being converted to chloride. Alright, so the steps, if you look up at the top, we want to follow these steps for each side. So the first thing is to balance the atoms. Here we have 3 in 1, so I'll add a 3 out in front, and so that's done. We don't need to worry about balancing oxygen or hydrogen because there isn't any. We do need to balance charges, however. So here we have 3, now -3 on this side, -1 on this side. We're going to add 2 electrons to make it -3 on both sides. And remember that oxidation means loss of electrons. So here we're showing a loss of electrons. With reduction, we want to balance the atoms. So here chlorine is balanced, oxygen is not, and we can add water to this side to balance out the oxygen. We've added 1 molecule of water to give us that 1 oxygen. Now we have to add 2 hydrogen ions in order to balance out the hydrogens. And the last step is to add electrons to balance the charges. So overall, on this side we have +2 and -1, so it's +1 here, and it's -1 here. So here we're going to have to add 2 electrons. Alright, so we want to now add these 2 reactions together. Here I'm just rewriting everything. And here is the reduction half reaction. I'm going to add the electrons over here because I'm running short of space. And then chloride is here, and water. Okay, so I want to try to simplify this by adding these reactions together. So I want to look to see if they're the same thing on either side. Here I have 2 electrons and 2 electrons, so those will cancel out. If they did not cancel out fully, you'd have to take everything in one particular reaction times an integer like 2, 3, or 4 to get it to be the same number of electrons. So they cancel out here, nothing else simplifies, so what's left over is what you'll keep. 2 hydrogens, 3 iodide, and 1 hypochlorite. And here's what we have on the right-hand side. So we want to check for atoms now. We have 2 hydrogens here, 2 here, 3 iodide, 3 iodide, 1 chlorine, 1 chlorine, 1 oxygen, and 1 oxygen. The charge overall is positive 2 and negative 4, so it's overall negative 2, and here overall negative 2 as well. So this is our final answer. And that's all.